Question 37. A molten carbonate fuel cell uses a molten mixture of lithium carbonate and potassium carbonate as the electrolyte. Hydrogen gas, I've just got my pointer, is passed over one electrode, and a combination of oxygen gas and carbon dioxide gas is pulsed over the other electrolyte. So it's giving us the reaction at the cathode, okay, with the oxygen and carbon dioxide, and it tells us in the question that hydrogen gas is passed over the other electrode. Then if we go down and have a look at our diagram, and when I'm having a look at the diagrams, I like to annotate them as I'm going, okay, just to help me understand what the question's asking. So if I have a look at my diagram, I know from this equation here that this tells me this is the reaction occurring at my cathode. So I've got oxygen and the carbon dioxide. So over here on my right, I've got my carbon dioxide and I've got my oxygen coming in. So this means that this side is my cathode, okay, it's positive. Then this must mean that this other electrode is the anode, which is negative, where the hydrogen gas is coming in. And I've got my electrolyte, okay, it's a carbonate ion, okay, it's negatively charged, so I know that an anion will be attracted to the anode. So I know my electrolyte will flow, or the ions will flow towards the anode in this fuel cell. Then I'm going to start looking at the questions. So the first question says, write a half equation for the reaction at the anode. Okay, so it tells me it's a half equation. The word half equation is used to describe half an equation for redox reactions. Okay, so it's either going to be a reduction or an oxidation equation, and I'm going to be including the loss or the gain of electrons. So this is what it's asking me to do. So it's write a half equation for the reaction at the anode. I know that oxidation occurs at the anode, and when I was reading my information here, I summarized that at the anode, I've got my hydrogen gas coming in. So I've got my hydrogen gas coming in. Excuse my writing. I need to get a fancy pen like this for you. So I've got my hydrogen gas coming in. At the anode, it's undergoing oxidation. So that means it's going to lose the electrons, forming my hydrogen ions. And it's lost 2 electrons. Okay, good. Okay, so that's 1 mark. Okay, so I've written the half equation for the reaction at the anode. The next part is that I need to, it says the product at the anode, okay, so that's my hydrogen ions, reacts with carbonate ions at the electrode. Okay, so that was, seen that in the diagram. So I've got my carbonate ions, they're negatively charged, it's an anion. They're going to move towards the anode. So it says write a balanced equation for this reaction. Okay, that's worded a little bit different from A. So if I read A, it says write a half equation. And if you remember, a half equation is showing redox. This is just asked for a balanced equation. And this is where a few people in class were getting a bit confused. So if it's a balanced equation, I don't need to, it's not a redox reaction, so I won't be including any electrons. Okay, nothing's lost or gained electrons. Okay, it's just a balanced equation. So the product at the anode, okay, so that's my hydrogen, okay. I have my 2 hydrogen ions. Okay, so I've got my 2 hydrogen ions, and it's reacting with my carbonate ions. So it's up there, it gives me CO3. Yep. Sorry, not very fast with this. CO3, 2 minus, and that's liquid. Okay, so I've got it's reacting with that, okay. If I look at the diagram, it tells me what these products will be, because it's showing me that water and carbon dioxide are coming out. So that has to be my products. So I've got plus, or excuse me, water, liquid, plus carbon dioxide gas. Okay, so again, that's not a redox reaction. It's just a balanced equation. I've got 2 hydrogen, 2 hydrogen. Yep, 3 oxygen. Yep, that's balanced. Okay, and that's part B. C, write a balanced half equation for the overall reaction occurring at the anode. Okay, so in part A, I had to write the half equation. So that was my hydrogen gas was undergoing oxidation. It lost 2 electrons. Those electrons go across, react over my cathode. And then my electrolyte moves across and it was reacting with my hydrogen ions. Okay, so what it's asking me to do is to put these two equations together for an overall reaction. Okay, and it's a half equation, so I would be expecting there to be electrons in there to show, okay, because it's going to be a redox reaction. So if I look at my two equations, I just need to add them together. However, I've got 2 hydrogen ions here, so they will cancel out. Okay, nothing else is the same. Okay, so I can't cancel out anything else. So all I do is I simply add together the remaining things. Okay, so hydrogen gas plus my carbonate. It's taking a long time. I need a pen. Okay. H2O. Okay. I'm going to stop writing state. Oh, I'll write state. Oh, that's a gas. There you go. Helps if I read the diagrams correctly. That's a gas. Okay. Plus, what have I got left? CO2. Gas. And don't forget the 2 electrons. Okay, so that's the equation overall. Okay. Then part D, write a balanced equation for the overall reaction. Okay, so that's asking me what is the equation overall that's occurring at the anode and the cathode. So in the question, I was given the reaction at the cathode. I've worked out the balanced half equation for the anode. I need to pop those two together. Okay, so if I'll change color pens, pen options, ink color, we'll go blue. Okay, so before I start putting them together, I've got 2 electrons here. If we remember when we were writing the redox reaction or balanced redox equations, we had to make sure the electrons were the same. So this was 2 electrons, this is 4 electrons. So I need to double this. Okay, so I'll double this equation. So I'll just double this now. 2, 2, 2. That looks like 3, but it's 2, 2. Okay, so they've now got the same number of electrons. Okay, so then what we can do is we can cancel out things so that it's the same. So I've got 4 electrons there, 4 electrons, got 2 carbon dioxide, 2 carbon dioxide, 2 carbonate ions, 2 carbonate ions, and all I'm left with overall is 2 H2 gas plus the O2 gas at the top, 2 gas, which gives me 2 H2O, and that was a gas. Okay, and that is my overall reaction, taking the anode and the cathode together. Okay, question E. On the diagram above, label the cathode and its polarity and the direction of the electron flow. Okay, so I'd already done that when I read my information. Okay, so as I said earlier, when I tend to read the information, look at the diagram, I tend to annotate the diagram as I go because I find it a little bit easier to help me understand what the question's asking. So I labeled the cathode and its polarity, so that's my positive, so cathode. And the next question, cathode. Okay, the direction of the electron flow. So we know that electrons flow from my anode to our cathode. Okay, done. Next, question F. Does the molten carbonate fuel cell produce any net carbon dioxide emissions? Justify your answer. Okay, so when we go back to our overall equation, we can see here that I'm just producing water. Okay, so produce any net carbon dioxide? No, it doesn't. Because I'm not going to write this technically. Because the only product is water. Okay, so there's no net carbon dioxide emissions because overall we are just producing our water as a liquid. Okay, from the fuel cell itself.